Chapter 8 talks about not looking at a single observation, but Chapter 8 says, you know what, we're going to look at samples. One observation out of a population isn't near enough to tell me anything. So what we're going to look at are samples. We're going to take a group and we're going to see, how is this group going to be used to tell me about the population? So when we get a sample mean, that's an estimate of the mean of the population. How good of estimate? Well, what we're going to notice is the central limit theorem that tells me if my sample size is large enough, if I take a large sample, it's going to have this sort of distribution so that I can use my tables. How do I know that? Well, if you think back in Chapter 8 in the lab, actually it was your homework, and you had this sheet of paper with all these circles that had numbers in them, and the mean of these circles was 3. But if I looked at the distribution of those numbers that you had, they were uniform. But if I was to take all samples of size 2 that were totally possible in this group, that would be a lot of samples. And if I plotted them, I would come up with this picture. In other words, I would get quite a few of them in this center, but I would get some that might be over here, large, and some over here that were smaller than 3, but would follow this. Now, kind of the neat thing about this is if I take and look at all the sample means that I could possibly get from a population and plot them, they would form a normal distribution. Because of this, if my sample size is large enough, I can assume a normal distribution so I can use my tables. So what we want to be able to do then is say, is my sample size large enough, and how large does that need to be? The other thing we want to notice, if I'm looking at my population distribution, let's suppose this is my sample mean distribution. If I'm looking at my population distribution, it's going to be much more spread out. I just like to use this idea of age at SKC. I had a student one quarter, Hap, who was 89 years old, and I had Anastasia, who was 16. Notice the spread. That's a lot of spread. If I was to take samples of size 2, Hap would get averaged in sometimes with a young person and sometimes with an older person, but he still wouldn't be as old as 89. And Anna, the 16-year-old, Anastasia, would be averaged in with people that were older than her, so she would never be at that 16. So what happens is, when we start taking samples and looking at the information, the standard deviation of the sample means is smaller. So how smaller? It's called the standard error. And I don't care if you remember that, but what I want you to know is it's smaller based on the size of the sample. That happens when we look at sample means. Now, we didn't use this before in Chapter 6 because our sample size is 1. If I was to plug it into here, the square root of 1 is 1, so I'd be back just to using the standard deviation. But what happens here is the standard deviation of the sample means decreases, gets smaller, due to this idea of averaging. So in order to use all of our information from the normal distribution, we need to make sure that a couple things are true. The first is the central limit theorem. To use the central limit theorem, it says my sample size of 30 or more is going to be large enough to assume that I'm going to follow a normal distribution, even though my population didn't. My sample means will. And because I'm looking at the sample mean, I can use a normal distribution. Is the sample mean always going to be the same as the mean of the population? No, it's not. That's why we say it follows this distribution. If I look at all my sample means and I graph them, I'm going to get this distribution. I'm going to get a bunch in this area, and if you recall, that lab was around 3, but I am going to get some on the tails that are large, much larger than 3, the average, and I'm going to get some on this tail, which means they are smaller. And so because I'm using a large sample Because of the central limit theorem, I can go back to this idea of a normal distribution. This takes place when you are using large samples. It happens because if I was to plot them all, we would have this distribution that would be normally distributed. So if I am looking and I have a population and I was to take 87 samples of size 4. So in this case, n, the size of my sample is 4, but I took 87 samples. And if I was to plot them on here, this is what my curve would be looking like. And guess what I would get here for the mean of my sample means? I would get them to also be the same value as my population, because your sample mean is going to estimate your population mean. Not exactly, but it's going to follow this normal distribution. So I know it's all going to clump to the center. Now that's important because we want to use those tables about normal distribution to figure out the probability. We know it's not exact, so there's a chance I'm going to be off, and so we want to use that probability then to help me make decisions about how far I might be off, how likely would it be that I landed in that particular position.